Perhaps the simplest system of encryption is to replace each letter in the alphabet by another letter. So for example, we might replace A by P, and B by U, and C by R, and so on. But such a method is very easy to crack because, for example, the letter E is the most common in the English alphabet, most commonly used. And if one were to do a frequency count of the number of letters in the encrypted message, it's quite likely that N would turn up, and you could make a reasonable guess that that in fact encrypts the letter E. A little bit of trial and error in this manner will easily break this method of encryption. It was actually used, however, by Julius Caesar about 2,000 years ago. One could conjecture that his opponents perhaps were not particularly literate in written Latin, and perhaps on seeing this thought that it was another language altogether. In any case, one could replace blocks of 5 letters instead of blocks of individual letters. One could even replace, and that's easy to crack by a computer, and one could also use blocks perhaps of 80 letters, or one might think one could. However, this would require a code book with 26 to the power 80 entries, because you would need to have 26 possibilities for the first, 26 for the second, 26 for the third, up to the 80th letter in the block. So that's not very practical. So here is a comparison of standard with RSA encryption. And when I say standard encryption, I mean something perhaps much more sophisticated than the simple versions that we gave before. In any case, with standard forms of encryption, if one knows how to encrypt a message, then one can reverse the process and decrypt the message. But in the case of RSA, everybody can encrypt using the public number provided by Bob, but only Bob can decrypt messages meant for him. In the case of any standard form of encryption, code books and encryption machines can be lost, stolen, intercepted. But in the case of RSA encryption, there is no secret code book, no encryption machine that can be stolen. Everybody uses the same encryption method, except that the number which is used is provided by Bob or whoever else the messages are going to be sent to. And sophisticated frequency analysis can often decrypt messages with standard type encryptions. But in the case of RSA, frequency analysis does not work because we are actually encrypting not just 1, not just 10, not just 20, but perhaps a couple of hundred letters at a time.